All right. Good morning. Good afternoon. My name is Mr. Mulenga. Today we'll be looking at mathematics with a topic called earth geometry. Today we'll be looking at earth geometry. Earth geometry is a very important topic. For those that want to do aviation, it enables you and I to know how to calculate time between 2 points that are located in different regions. Okay, it also enables us to know why is it that when you're in here and then maybe people in America, the time is not the same because they are located in different geometrical points. So there are many more importance that we can pull out from the study of this topic. So for now, I'm going to introduce you to it, then also give you some more highlights of the topic. So we're looking at the earth geometry. Earth geometry. To start with, I'm going to give you the introduction of the topic. Okay, I'm going to give you the introduction of the topic. So let's consider the earth. Consider the earth. We know that the earth is spherical. We know that. We know that the earth is not flat. It's not flat, but spherical. It's spherical in nature. So if you get to have a sphere, a spherical shape like this, you'll find that we have the lines. We have the lines. Okay, the point on top is the North Pole. The point at the bottom is the South Pole. And then we have lines that run from the north to the south. Like that, we have these lines. What are they called? Okay, we have these lines that run from the north to the south. So these lines are called longitude. So this is a longitude. Okay, so let me say all these lines that run from the north to the south, all these lines, they are called longitudes. All of them are longitudes, and they are equal in length. They run from the same point from the north up to the south. These are what we call longitudes. Longitudes are very important lines because these are the ones that we'll be dealing with when we start looking at time difference. So we have the lines that run from the north up to the south. These are called longitudes. Okay. Then we also have lines. We also have lines that run from the left part of the earth is the west. Then this one is the east. So we have lines that run from the west up to the east. These lines here, from the west to the east, in that arrangement. So these lines here are called latitudes. So this one is a latitude. Now what can we say about longitudes? These lines run from the north to the south. They run from the north to the south. What can you say about them? They are all equal in length. They are all equal in length. Because they run from the same point, which is the northern point, up to the southern part. They are all equal. What else can you say about them? Uh, they are used for time allocation, time calculation, I would say. So when you're calculating the time between 2 points on the earth, these are the lines that we refer to. Now, how are they? Because they are moving from the north to the south, and then they're moving from the north to the south. But if you get to have a compass, like this, east and north, south, west, because these lines are moving from the north to the east, from the north to the south in that direction. If you are to demarcate now the earth into a north, south direction, if you are to demarcate the earth into that way, you find that you're going to have some lines that will be on the east among the longitudes, some lines will be on the east, other lines will be on the west. Okay, so among the longitudes, some are on the east and others are on the west. So what can you say? You can say they can either be eastings or westings. Let me say they can either be on the east, or only on the west. So I say these lines are running from the north to the south in that vertical direction. We can have some lines. We have some lines on the east, others are on the west. So because of that, we are saying they can either be on the east or they can be on the west. Now, basing on that direction, from this point now going to the east, what happens? And from this point going to the west, what happens? So we are saying from this point, from there's a line which is drawn here. There's a line which is drawn facing us, which is at 0 degrees. That line is called Greenwich meridian. There's a line which is drawn here at 0 degrees, and that line is called Greenwich meridian. So from the Greenwich meridian, considering these longitudes going to the east, what happens? You will find that the size of the degrees must increase due east. I'm saying that from the Greenwich meridian here, going to the east, this side, the degrees increases. So from the Greenwich meridian to the east, they increase eastwards. What am I saying? Moving from the Greenwich meridian, which is at 0 degrees, going this side, the size of these longitudes increase. In a similar manner, from the Greenwich meridian going to the west, degrees the size of these longitudes. How do you distinguish them? By the size of the degrees. So find that even these that are found on the left also increase westwards. Those are two things that are going that go out for now. On the longitudes, there much more that you need to know, but for now, let's go back to the latitudes. What are a few things can we learn from them? Latitudes. What's the opposite to longitudes? latitudes. These latitudes that are here, that are positioned horizontally, these lines, we can call these horizontal lines that are on the Earth crust. But how are they? You find that they run from these latitudes, they run from the west to the east. That's how they move, in that the Earth rotates. As the Earth rotates. Do not confuse them between the longitudes and the latitudes. Okay? So I'm saying these are the latitudes that are positioned horizontally on the Earth crust, but we can say that they run from the west to the east. That is how they are in that arrangement. But these lines here are not equal in length. They are different from the latitude. The longitudes say they are the same because they move from the same point up to the starting point of the longitudes and the end point. They are just the same. However, these latitudes is not the same. Here, if you get to have an orange, you slice it in the middle. The cross section you're going to have of an orange will not be the same as when you slice an orange towards the end. So because of that, the size of the latitudes are not the same. Yeah, so we say they are not equal in length. They are not equal. No. That's what we can say. Now, if you look at these latitudes that are being represented by the east-west direction, these ones here, we are saying some of these now, if you look, if you have this number, this line which is at 0 degrees, which is the equator, this line is a reference point, the equator. From the equator going up, these latitudes that are going to be denoted by the north. So we're saying from the equator, we have this equator demarcating the Earth into two parts. We have this part on top. So those latitudes that will be found on top, we're going to call them northings, or we can call them we can say they are found in the north. And these ones that are down here on the southern hemisphere, we're going to say that they are going to be denoted by southern. But what can we say? We are saying they can either be on the northern hemisphere, and these ones are denoted by the N, or the southern hemisphere. By southern hemisphere. In a similar manner, those that are on the northern hemisphere, from the equator, the size of because this is 0, remember this equator is 0. So from the equator going up, the size of the latitudes increase. In a similar manner, in the southern hemisphere, these latitudes that are found in the southern part of the hemisphere, from the equator going downwards, the size of these latitudes increase. That's the first point. Then the second point is now, how do you denote, or how do you give the definition or the description of a point on the Earth crust? The point is very important. Just like in the Cartesian coordinate, you will find that a point on the Cartesian coordinate is denoted by the x coordinate as well as the y coordinate. Not talking about the polar coordinates here, we're talking about the Cartesian coordinates. So I'll take you to the Cartesian coordinate. The Cartesian coordinate or x or y plane, this is the y and this is the x. If you get to have a point here, this point here will be denoted by the value of x from here, also the value of y from the y-axis. So from here, we can get this principle, we can borrow it from there and take it to F geometry. You will find that the lines, if this gets to be our F, this gets to be our F, the lines that are being represented by the x-axis is the latitude. And then the line that is being represented by the y-axis is the longitude. So, from here, we have an idea to say a point on the F is denoted by latitude d, comma, longitude, just like the x or y plane. We say this point is denoted by the x, latitude, comma, the y, which is represented by the longitude. So that is the principle that we need to borrow. So let's go to point location. How do you locate a point on the F or on the globe? So we can say a point location. Points location. So we're saying a point on the F crust. F crust. And we're going to use the word globe. The point on the globe is denoted by the latitude, comma, that is the point that we need to remember every now and then, that every point you pick on the globe, how do you locate that point? You denote the point by the position on the latitude, comma, the position on the longitude. That point is very important. So if you look at example, we can have the F, can have the globe. It's not drawn to scale. It's not drawn to scale. This thing here is not drawn to scale. So if you have a globe drawn like that, if you have a globe drawn like that, with points, so this is the north here, we only have two longitudes, south here, then you also have only two longitudes and two latitudes, sure. Okay, so this is 80 degrees north, 30 degrees south. This line here is 105 degrees east, and this line here is 15 degrees west. Then the question goes like give the coordinates. Give the coordinates or locate the following points. So what points are they? This point here is W. This point here is W. This point here is x, this point here is z, and this point here is y. The following points: A, we have x, and B, we have y, C, we have z, and D, we have w. So these are the 4 points that we are going to look at. How do we locate them? Remember, the point which is our guiding star, say a point on the globe is denoted by 1, consider the latitude, second, consider the longitude. So this one is the coordinate, or you say the position, give the position, or locate the following points. So how do we locate them? If you look at the first point, which is our x, where is our x? Our x is here. So what is the latitude on which point x is standing? So what is the position, or what is the latitude on which x is standing? And you will find that x is standing on the latitude, because I said the latitude can either be on the north or on the southern. So this is the longitude on the northern, and the latitude on the south. And I also said these longitudes that are denoted by the Greenwich meridian, you can have some on the east, you can also have some on the west. So looking at point X is standing on 2 lines, the latitude and the longitude. But remember, we're going to start with the latitude. So what's the position of the latitude at X? X, the latitude is 80 degrees north, comma, then we give the position of the longitude. The longitude is this one, passing through point X, and it is located on latitude 105. So it is 105 degrees east. So that's how we can give the position of the point on the globe. Which other one? We're done with X, let's go to Y. Y is right here. So likewise, we're going to do, we start with the latitude, we separate the comma, then we go to the longitude. So what is the latitude here? Our latitude now is in the southern hemisphere, which is 30 degrees south. So Y is 30 degrees south, comma. What is the longitude? Now the longitude is different from the one where X is. But be reminded that W and Y are on the same longitude, W and X are on the same latitude, X and Z are on the same longitude, Y and Z are on the same latitude. Do not get confused. So Y, you say Y is on latitude 30 degrees south, and then the longitude is 15 degrees west. So it is 15 degrees west. It is a very simple task, actually. What about Z? The Z here is on the latitude 30 degrees south, so is on 30 degrees south, comma, and the Z, the longitude where it is standing, the size of the longitude is 105, which is 105 degrees east. What about W? W is now right over here. You will find that the latitude on which W is sitting is the latitude is the same as X, which is 80 degrees north. So which is 8 degrees north, comma. Then the W, the longitude on which it is sitting on the longitude 15 degrees west. So, comma 15 degrees west. Simple as that. Remember, we are borrowing the concept from coordinate geometry. We always start with the x-axis. The line representing the x-axis is the latitude. That's the reason as to why that point you start with the latitude, then you go to the longitude. The last point for today The last point for today is how to calculate the degree difference. How do you calculate the difference between those degrees that we have? Right, right. How do you calculate the degrees? How do you calculate the degrees? Now, bear in mind that the degree difference is you cannot compare the difference between the longitude and the latitude. When we start looking at the degree difference, we will be looking at the latitudes first, then you go to the longitude. So we are going to call it degree difference. Degree difference. Degree difference. That is the last concept that we're going to look at today. The degree difference. The difference in those degrees. But we're not going to look at the degree difference between a point which is standing on a different longitude and the different latitude. That's going to be a bit tricky. So I'm going to pick only, we can start with latitudes. How do we find the difference? Remember, I said these latitudes can either be latitudes, can either be north or can either be north or south. So now, if you get to have a point, that is sitting on two different latitudes, but one latitude is on the northern part, then the other one is on the southern part. How do you find the difference? So that's the first point that I'm going to bring to you. So we say if 2 points are on different hemispheres. We're talking about the latitude, so we're going to have northern hemisphere and southern hemisphere. So if different hemispheres, that means one on the north and the other one on the south. North and south. How do you find the difference between them? The difference is found by adding. So all you have to do is do a you add. The good example that we can look at. Okay, I'll come and draw the diagram which will combine the two. So what I say is if 2 points are on different latitudes, one on the northern hemisphere, the other on the southern hemisphere, to find the difference, do not get confused by saying the word difference means the answer you find after subtracting. But here, the position matters. So the positions are one on the northern hemisphere, the other one on the southern hemisphere. To find the difference, all you got to do is just to add them. So you add. That's how you find the difference. Then the other point is that if 2 points are only the same now, on the same hemisphere, but here it can be one north, another one north, or the other one south and another one. If you have one south, then the other one south. Meaning you can have both on the northern hemisphere, or both on the southern hemisphere. To find the difference, we are no longer going to add, but what we are going to do, subtract. Subtract them. So based on these two, I'm going to draw a sketch diagram of the globe, which will have these theories talked about. Okay, we're going to have sketch, which will have these two theories to talk about. So perhaps I can borrow even the same diagram that we had. Can borrow the same diagram that we had. So if this is the north and this is the south, so you can have the longitude here and the longitude here. This one was 15 degrees west. This other one here was 105 degrees east. Then we had the first latitude on the south, on the northern hemisphere, which was 80 degrees north. We also had another one on the southern hemisphere, which was 30 degrees south. So now, how do you find we're saying, and now we're considering the latitudes. How do you find the difference between the points that are on the same side or opposite sides or different sides? So let's consider those points. So we're going to look at this one here is W, this one here is X, this one here is Y, and this is Z. So let's see how we can consider. Maybe I can also have another one here. Allow me to put up another one here, which will be 12 degrees south. And I'm going to put this one point A, and I'll put this one point B. So now we say find the difference between the difference between W, which is on the northern hemisphere, and the A, which is on the southern hemisphere. So between W and M, the other one we can look at now, B, which is on the southern hemisphere, and Z, which is on the southern hemisphere. So between B and Z. But remember here, the coordinate from the latitude is not that important because we're now just dealing with the latitude. So if you can allow me to forget about the longitudes, let me just concentrate on the latitudes. So let's consider where W is. W, the latitude, is 30 degrees north. So W is 30 degrees. Sorry, it's 80 degrees north, and A is 12 degrees south. 12 degrees south. So what are we going to do to find the difference? Because these guys are only different hemispheres. W on the northern hemisphere, then A on the southern hemisphere. To find the difference, we're going to add. So therefore, to find the difference between W and A, the difference will be 80 degrees. Forget about the direction now. 80 degrees plus 12 degrees, and the answer will be 92 degrees. So that is the difference, that's a degree difference between W and A. W is on the northern hemisphere, A on the southern hemisphere. Like the first point was saying, what I'm going to do is to add. Then B we have B and Z. B and Z, but let's remind ourselves, where is B? Let's forget about latitudes for now. B is 12 degrees south. So we have 12 degrees south for B, or no, that's for B, yes. And for Z, so maybe this might be confusing. So let me say B is 12 degrees south, and the Z here is 30 degrees south, which is 30 degrees south. So now to find the difference, what do we do? Both of them are on the same hemisphere, northern hemisphere, northern hemisphere. Therefore, to find the difference, we're going to subtract the two. So 30 degrees minus 12 degrees. And what will be the answer? The answer will be 18 degrees. Yeah, so that will be the size of the difference, the degree difference between 2 points that are on the same hemisphere. All you have to do is to subtract. So the same principle that you've applied on the latitude, it's the same principle that you also apply on the longitude. If two longitudes are on the same part, east, all you have to do is to subtract them. And if the one is on the west side and then the other is on the east side of the globe, all you have to do is to add them. I'm going to put that later. So we just from looking at the latitudes. Now the last part, let's see how we can play around the longitudes. Be reminded that regardless of the line that you're considering, provided they are of different sides over the globe, the difference is add. Same side, the difference is subtract. So now we'll be looking at longitudes. The similar manner, if 2 points are only the same side. So because these are longitudes, same side, we can have west, or we can have east. To find the difference, all you have to do is subtract, like we did for latitudes. That's the first point. And the second point is if 2 points are only different sides, meaning one being on the west, another one on the east, all you have to do is you add them. All you have to do is to add them. When you add them, what you get to have is the difference. So let's look at the last example. We can have the globe, which is difficult to draw freehand. This will not be drawn to scale. Okay, that is our globe. So if this is our globe, we can have right this minute. I'm just going to use coordinates of my own. So we can have the north here, okay, then the other one here. I'm not even interested in these latitudes anyway. Then again, you have another one here. Okay, so we have this point here, point A, this point here, point B, this point here, point C. Yeah. Okay, sorry about that. Then the question will be like, find the difference between what and what? between this is the last part, between okay, let me give the position. This is 50, this is 50 degrees, 50 degrees east. This, the first one here is 40 degrees west. And the second one is because they are increasing, so we can have 75 degrees west. That one and one. Okay, so between point, given latitudes, between point A and B, and then the other one will be between point B and C. So if you look at the way the questions are, they're not too different from what you've looked at. Because point A and B, if you can look at them, 75 degrees west, 40 degrees west. So between A and B, because these are on the same side of the globe. So to find the difference, what we're going to do is to subtract. So what is point A? Point A here is on the latitude. Point A here is on the latitude 75 degrees west. Then B here is only 40 degrees west. So because both are on the same side of the globe, you find that the difference will be found by subtracting 75 degrees minus 40 degrees. And you find that the difference will be 35 degrees because they are on the same side. But for B and C, to find the difference, look at B. B here is 40. B is 40 degrees west. Then C, what about C? C here is 50 degrees east. 50 degrees east. So to find the difference, we're going to add 40 degrees plus 50 degrees, and the answer gets to be 20 degrees. That's how easy it is finding the difference. So far, we've looked at two important concepts. One, how do you locate the point? Then the second one is how do you find the difference? So do not forget that, because the next time we're looking at how to find the distance. Now, the distance between point A and B. There again, it is very important. You need to understand the points where the position of those points, whose distance you want to determine. Are they on the same side? Because if they are on the same side, then you know what to do. Because angle